Hi, this is Kenny from In-A-Day Development. Welcome to our tutorial on the advanced statistical functions. The 10b2 cache calculator, like the physical HP calculator that inspired it, has a variety of statistical functions it can perform for you. If you haven't watched the videos for entering statistical data or the basic statistical functions, head over there now, as it covers the basic mechanics of how to get your statistical data points entered and a few things that you can do with them. Okay, so we'll set up the same data points that we used in that video, namely 1010, 30, 11.2, 50, 14.7, and 70, 16. Now that we've got that set up, we hit Done and head back to the main calculator. Okay, the orange shifted statistical functions are a touch more complicated than the blue shifted statistical functions. The reason I say they're complicated is that each orange shifted statistical function actually has two functions, and you switch between them using orange shift and swap button. So let's try it out. Showing the 7 button is the arithmetic mean function, also known as the average. So I hit orange shift, arithmetic mean, and see that the mean of my x values is 40. I hit orange shift and swap, and see that the mean of my y values is 12.98. Sharing the 8 button is the sample standard deviation, which assumes that the entered data is only a sample of a larger, more complete set of data. I tap orange shift, sample standard deviation, and see that my sample standard deviation of the x values is 25.82. Orange shift and swap tells me that the sample standard deviation of my y values is 2.84. The orange side of the 9 button is the population standard deviation button, which assumes that the data points I entered earlier are the entire set of data. I hit orange shift, population standard deviation, and find that the population standard deviation of the x values is 22.36. Orange shift and swap tells me the population standard deviation of the y values is 2.46. On the 4 button is the x hat r function, which gets you the estimated x value given an entered value of y. Swapping gets us the correlation coefficient, which is a measure of the correlation or linear dependence between two variables x and y, given a value between 1 and -1 inclusively. It is widely used in the sciences as a measure of the strength of linear dependence between two variables. So my first step is to enter a y value for which we want to find our estimated x value. Let's say 18. So I enter 18, then orange shift and x hat r, and see that my estimated x value is 86.74. I hit orange shift and swap and see that my correlation coefficient is 0.98. On the 5 button is the y hat m function, which gets you the estimated y value given an entered value of x, and swapping gets you the slope of the calculated line, which is the calculator's best attempt at finding a line that fits all of the data points pretty well. Since I want to find the y-intercept of the calculated line, I'm going to find the y value when x is 0. So I enter 0, then orange shift and y hat m. I see that my y-intercept is 8.68. My slope is, orange shift swap, 0.11. So my line is pretty close to horizontal, not steep at all. Lastly, we get to the weighted average, which takes each x weighted by its corresponding y and finds the average. So I hit orange shift, weighted average, and get 44.14. Thanks for watching. If you have any questions about this example, please feel free to email us at theteam@inadaydevelopment.com.